Okay.
We are beginning with the layout. What is layout and what is the importance of that? Layout is actually, I should give you an analogy where you might have seen civil engineers drawing the layout of a house which has to be constructed in future. Say for example, if I draw a house this way, you will not come to know how many rooms are there, how big is the hall, okay, how big is kitchen and bathrooms and all. You will not come to know. But if I draw the layout of that house, indicating with some, say this is door, main door. So main door is having some lines like this. Okay. Then I have, say, master bedroom, which is dotted. Some indication. Okay. Say I have in the entrance I have hall. Hall is having shade like this. So this shade indicates hall. Then I have, say, here I have bathroom. So some other indications. Okay, some other indications. Then here also, say, storeroom. Then I have kitchen. Okay, again bedroom, like that. Some indications will be there. When we see this layout, we will come to know, okay, how the house will be built. In the same way, in Vlsi, when we actually design the circuit, we will be designing it in terms of nanometers. Everything is in nanometers. We all know that. Okay, transistor nanometer, wire length nanometer. Okay, everything is in nanometers. So, like we have some indications for these terms. Wall is this way, like that. Okay. In Vlsi also, we have some indications. We call those indications with the term called as layers. Okay. Say for example, I have something which is called as metal 1. Metal 1. Okay. How it is represented? Actually, the color of that metal 1 is blue. In layouts also, people will be drawing the layouts in lab. So when you draw the layouts, you will come to know. Even the color will appear blue in the software. Okay. So metal 1 is represented with this pattern, which is blue in color. What is the use of metal 1? Metal 1 is used as wires. Okay. Say I have an inverter. So, in inverter, I need to do the connections. So this is one connection. This is VDD. VDD to MOSFET, some connection will be there. Again, this MOSFET to ground will connection will be there. So all these connections, this connection, all these connections, okay, this connection and the output. Even this connection, all these connections which are done through wire, okay, that wire is taken as metal 1 in Vlsi. So, either connection model we will use metal 1, right? And sometimes metal 1 is going like this. Okay. I want to do one more connection from here to here. So but these two should not be connected. One wire go back, one wire go back. Okay. But these two should not short. At that time, what we do, this is one wire. I'll take this wire, I'll bypass it. I'll take a flyover. You have seen flyovers. Okay. So, so when we don't want these to collide, or when we don't want the things to be shorted, if I short our design, then what I do, I'll just take a flyover. So for taking a flyover is constructed on another floor. same floor पे work करते हैं correct activity. So it elevates and it goes above. Okay. So like metal 1, we have metal 2 also. Metal 2. Job of metal 1 and metal 2 are same. This is also used for wiring. Wires are only used practically. Okay. So it is represented with this pattern. It is represented with this pattern. Fine. Next. Next we will take something called as P diffusion. This is another layer which is, I can say, half transistor, not full transistor. I'll tell you when it becomes full transistor. And similarly, we have something called as N diffusion. What is the difference between P diffusion and N diffusion? See, the pattern of this shade, this pattern is similar from right to left. Only difference is the distance between the two lines. In N diffusion, we are drawing very close lines. This indicates it is N diffusion. This is P diffusion, where the distance is little more. Okay. Then we have something called as poly. I'll tell each and everything. Poly is represented with this pattern. Left to right shade will come inside the poly. Okay. So I was telling this is half transistor, this is also half transistor, this is also half transistor. In general terms, when it will become full transistor? When it will become full transistor is when this poly will cross this P diffusion. Now you may get confused. Again confusion agbodu. This poly, okay, if I rotate like this, this poly if I rotate like this, right angle, 90 degrees I rotate, okay, towards right. So what you will think, shade should come like this, no? Shade should come like this, why it is like this? Don't get confused with that. Any of the layers, actually these layers are used for physical design or drawing the layouts. Okay. Any layer you take, okay, I'll take metal 1. If I take metal 1, if I draw like this, what do people will think? Okay, if I rotate like this, then the shade should come like this. But it is not the fact. Shade will be vertical. Always, however you draw, in hanger it is free, working pattern is identical. Hanger is hanger. Suppose if you draw metal 2, like this, internal pattern it will be same. It will not change. And there will be you draw however. Okay, one point I am making very clear. So I was telling you about this one. Okay. Now what is poly? Poly is actually the gate. Poly is nothing but gate of the MOSFET. Okay. And what is this P diffusion? P diffusion, when this one I call it as gate, then the other side of the gate will be source and drain. This side of gate will be source, this side will be drain, just like this. See, this is gate, this will be source and this will be drain. Or drain and source can be interchanged. This can be drain or this can be source. So when a poly crosses over P diffusion, it forms P MOSFET. P channel MOSFET. When this poly crosses over N type diffusion, this is N type diffusion. Okay. When it crosses this one, here it will form N channel MOSFET. So if I draw it, this entire square or rectangle, whatever, it is PMOS. How it is formed? Poly crossing over with P diffusion. This entire box is NMOS. How it is formed? Poly crossing over N diffusion. N diffusion means it is N channel. Conclude with. P diffusion means it is P channel. But I should have gate, then only transistor will be formed. So this is P MOSFET, this is N MOSFET. Okay. We will take examples, we will understand everything. Don't worry. You can layers on explain what is poly gate, what is P diffusion. You imagine it to be P channel. What is N diffusion? N channel. Okay. Then metal one, what it is used for? Connection, wire. Also metal one is used for this wire. VDD and ground also we use metal one. For VDD and ground also we use metal one only. Okay, so three options we make use of metal one. Wire connections, VDD and ground, all three. Okay. Then we have something called as contact cut. Contact cut. What is this contact cut? Contact cut is nothing but you might have seen two pipes of variable length. One pipe 2 inches, another pipe 1.5 inches. So there will be a connector in between. If you want to join them, you use one connector. Okay? So whenever I want to connect any two layers, I will make use of this connector which is called as contact cut. Contact cut. This use ಮಾಡ್ತೀವಿ. Just have patience of another 5 minutes, you will understand everything. Okay, this is contact cut. One more thing we have which is called as via. VIA, via. Okay. So just now I said you people, we have at the ground floor we will have poly. At the ground floor, now we are standing at first floor. We are sitting in first floor. Block number 6 is in first floor. Office is in ground floor. Correct? My cabin is in second floor. Okay. So if you people want to go to ground floor, how will you go? You have stairs. That stairs is nothing but wire. That stairs is nothing but wire. Okay, so it will connect one layer, any layer, generally say metal 1 or metal 2. Metal 2 to metal 1 connection if you want, we will use stairs in between. If I want to come to this class, I use stairs. Steps. If you people want to go down, you will again use steps. Okay. So one floor to another floor, if you want to make connection, then we will make use of this wire. Okay. So this is just introduction about different layers. Now in VLSI, we are playing with nanometers. Although this is a very interesting topic. Once I start, you will not leave. So in VLSI, we are just playing with nanometers. Wire is also nanometer, transistor is also nanometer, resistor is also nanometer, everything is nanometers. Okay. In nanometers, say this is one wire, nanometer. This is another wire, that is also in nanometer, and distance between these two wires is also in nanometers only. So close. Just imagine. Nanometers we can't see, even micrometers we can't see, but we are placing two wires which are separated from each other in nanometer scale. Okay, if you imagine, you will feel that there may be, they are so close, and they are very, very close. Okay. Then what we have to make sure, if these two lines are different lines, it should not be shorted. Okay. Then what we have to make sure, the distance between these two wires, which is again in nanometers, it should be maintained very well. ಇಲ್ಲಾಂದ್ರೆ ಏನಾಗ್ತದೆ ಹೇಳಿ, ಇದು ಸ್ವಲ್ಪ ಇದಕ್ಕೆ ಹತ್ತಿರ ಆತಂದ್ರೆ nanometer ಬಹಳ ಸಣ್ಣದ್ರಿ. Electrons, what they will do, they will jump from this line to this line. So close they are, nanometers. It will not take much time. So if electron starts jumping from one wire to other wire, it will create a problem. ಅದು separate ಇರಬೇಕಿತ್ತು, short ಆಗಿಬಿಟ್ಟೈತಿ. Or logic will fail there. AND gate will not behave like AND gate. Getting for that, because we are playing in nanometers, okay, some set of rules are formed. Those rules are called as lambda based design rules. Lambda based design rules. Okay. So I'll tell what is lambda based design rules. I'll tell. Okay, this is metal 1. Metal 1 minimum width should be 360 nanometers. For example, metal 1 minimum width should be 360 nanometers. Why like that? Because if the width of the wire is very, very less, then there will be problem for the current to pass through it. If you have to roll out. If you have to roll out, jaga bhal kadime ittira. Ishte jaga ittare ನೀವು ಓಡ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ರೆ ಓಡ್ತೀರಿ, ಬಡ್ಸ್ಕೊತೀರಿಲ್ಲೋ, ಖಾಲಿ ಬೆಳಿತೀರಿ. ಹೌದಾ? Same thing will happen there. If the width of this wire is very, very thin, very, very small, then there will be problem for the current to flow through it. Therefore, we will make sure that, okay, ಇಷ್ಟು current flow ಆಗಬೇಕಾದ್ರೆ minimum width ಇಷ್ಟು ಇರಲೇಬೇಕು. This is one point. And ಇದರದ್ದು width ಇಷ್ಟು minimum ಇಷ್ಟು ಇರಲೇಬೇಕು ಅಂತ ಹೇಳ್ತೀವಿ. And one more point, ಈ point ನ ಡಿಸ್ಕಸ್ ಮಾಡಿದೆ. Distance between these two layers should be minimum this much. Example, say 500 nanometers. For example, so distance between any two layers should be this much. This much. That this much is converted or is called in terms of lambda. Now, for example, if I am working on 90 nanometers technology, if I am working on 90 nanometer technology, andre 90 nanometer technology andra distance between source and drain will be 90 nanometers. That is length of the MOSFET. Okay, all MOSFETs will be of this length, 90 nanometers. Right? If I am working on 90 nanometers, let my lambda be 90. Let my lambda be 90. For example, I think if my lambda is 90, then I can easily say, okay, this minimum width should be 3 lambda. Because my lambda is fixed. Once my lambda is fixed, I can define all these, this much, I can define all these in terms of lambda. So this width, minimum width of metal 1 should be 3 lambda. Minimum width of metal 4 should be 4 lambda. Minimum distance between metal 1 and one more metal 1 should be 3 lambda. Minimum distance between metal 2 and one more metal 2 should be 4 lambda. Okay. To avoid the errors, to avoid the faults, to avoid the failures in the circuits, we are following some standards which will avoid the errors. Okay. So these things are incorporated within lambda based design rules. Say this minimum width is 2 lambda. Okay. This minimum width is also 2 lambda. Distance between these two is 3 lambda. And this minimum width is also 2 lambda. Okay. And distance between two polys should be 1 lambda. Distance between two polys should be 1 lambda. All these are listed, and I have shared the notes in your WhatsApp group. You can just open it. You can download it. You can open it. You can just see the list is there. What should be minimum distance between any two layers, and what should be the minimum width of each layer. Okay, that is there in that notes, module 2 notes I have sent you. For battery, just open it and see. So as I said, all these lambda based design rules are incorporated in your software. So you are working on cadence. Okay. Once you design circuits, okay, you have an option of drawing the layout. You have to draw the layout. We'll learn how to draw the layout. Once you draw the layout, you have to check DRC. Here there. DRC. DRC stands for Design Rule Check, which is lambda based design rules. And if you are violating any rules, suppose the minimum 3 lambda irbekitte, you 3 lambda ತಗೊಂಡಿಲ್ಲ ಅಂದ್ರೆ the software will give you error. The minimum width of metal 1 is less than 3 lambda ಅಂತ ಹೇಳ್ಬಿಡ್ತದೆ. Okay. So software itself is taking care of all the things. You will get the errors. One more option we have after DRC, we will check with LVS, which is layout versus schematic. LVS means in schematic design, this is called a schematic design. In schematic design, you have connected both the gates, sorted and giving the input. But while drawing the layout, if you are missing that, either hogi connect ಮಾಡಬಿಟ್ಟಿದ್ರೆ, it will tell schematic and layout are not matching. It will give again an error. So we have simulation software in that everything is programmed. Okay. Now let us go to the main aspect, that is drawing the layouts. Okay. So first let us draw the layout of CMOS inverter. CMOS inverter, we have schematic like this. So we have PMOS, NMOS, this is Vout, this is Vin, this is VDD, this is ground. This schematic we have, correct? You don't source anything, source, drain, source. Now we are drawing the layout of inverter. Okay, flux particularity is very important. The person who learns to draw the layout, okay, he gets the wonderful salary. Back-end designers antaragata, those who are drawing the layouts and designing the circuits, those people are called as back-end back end designers, and those people are paid huge salaries. My friend joined a company with the salary of 7,000 per month. Even I had that offer, okay, but I did not join. He joined. After 10 years, he is drawing today 7 lakhs per month. Only 7 lakhs per month. He is a back-end designer. Okay. So this is very important. Very, very important. Let's start with inverter layout. Let's go drill. First thing in layout, I'll begin with VDD and ground. VDD and ground is ಯಾವ layer use ಮಾಡಬೇಕು? ಯಾವ layer? Metal 1. So I will draw metal 1. This is my metal 1 layer. So this is my VDD. This is my VDD. Similarly, I will draw ground. Ground will be bottom because VDD top, ground is bottom. In I have to draw it neatly. I am not drawing it neatly because I have lack of time before. So this is VDD, this is ground. Okay. Next, you have to start thinking. Both the gates are shorted. Both the gates are shorted. Okay. And I have a common input. I have a common input. Now what I will do? I will take what is this layer? What are these layers? मैल बनते क्या layer? P diffusion. क्या बनते तो? N diffusion. Okay. Now I will take one more. What is this layer? Poly? Yes, correct. What is this layer? Poly. So what I have done? When poly crosses over the P diffusion, what it will form? P MOSFET. So this is another P MOSFET. This is another N MOSFET. I have P MOSFET, I have N MOSFET, I have VDD, I have ground. All four are ready. What I have to do? I have to do connections. But both the gates are shorted, and my poly represents the gate. So I short both the poly. So what I do? I take common input for both the MOSFETs, PMOS, NMOS. For both the MOSFETs, common input. Poly is shorted or gate is shorted. Therefore, I have shorted the poly. Clear? Next. VDD is connected to what? Source of PMOS. So you can take source any side. You can take source here also. If you take source here, this side becomes drain. Okay. And actually this is poly. So this is gate where I will give the input. Or I can write V in. V is given here. Okay. Next, what I will do? I will start doing the connection. Which layer I should use to do the connection? Metal 1. So VDD should be shorted to the source. VDD should be shorted to the source of PMOS. Similarly, source of NMOS is shorted to the ground. If I take source here, it is shorted to the ground. Drain of PMOS and drain of NMOS are shorted. This is source, so this is drain. So these are shorted. And output is from where? This point itself. So here only I can take the output. This is Y, which is output. Almost ready. One point is missing. I have to draw the contact cut. Where I have to draw the contact cut? Where I am making the connections. Okay, with different layers, not same layer. Now you may ask, sir, here also you have made connection from here to here, but both the layers are same layers, so need not draw the contact cut. But this is different layer, this is different layer, therefore I am drawing the contact cut. This is a contact cut, which indicates there is a connection. Here I have contact cut, here also I have contact cut. So this is the layout of inverter. This thing you draw it in your lab or software. Okay. See, this is P. Okay. So this P it is common for both the MOSFETs. So here also it is V only. This is common. Common as a single, which indicates that these two are shorted. Common gate completely. This is volume mode, it is gate. So common gate. Actually, here gate covered was short padi. ಅದನ್ನು ತೋರಿಸೋದಿಲ್ಲ ನಮಗೆ. Okay. ಇನ್ನೊಂದು ಹಿಂಗಿದ್ರೆ now you will understand. This is one poly, this is another poly, but both the polys should be shorted. Okay. Both the polys should be shorted. Therefore, what I do, I'll short it with the poly. Using poly, I'll short. Clear? Next, we will continue with 2-input NAND gate. 2-input NAND gate. Okay. So I'm just erasing this. So for 2-input NAND gate, again we require VDD and ground. So I kept it as it is. Again we will take P diffusion and say N diffusion. How many polys are required? How many polys are required here? 2 or 4 or ideally 4, but when you see A and A, B and B, they are shorted. So how many I will use here? I will use only 2. I will use only 2 because they are shorted. A to A short, B to B short. Okay, so this is my A and this is my B. Shading is like this. So these are my polys. I have 4 transistors. 2 PMOS, 2 NMOS. Okay. Photo battery, then VDD, VDD, ground, 4 transistors are ready. Now what we have to do? We have to connect them. How we have to connect? These two should be in parallel. These two should be in series. So this is source, drain. Here, drain, source. These things I have to make sure here. So what I will do? Source of both the PMOS are shorted and given to VDD. So what I will do? Here, if I take this as source, these two if I take source, the other side will definitely become drain. Okay. So what can I do? I can just take the connection of VDD at the source. and drain to drain should be shorted. So what I'll do, I'll take wire, okay, I'll short it with the drain. So this is connection between drains, drain to drain short, and from drain to drain short only I have the output. So I'll just take this output and call it as y divided by output. Okay. Then from output or from this point, where it is going? Where it is going? Drain of NMOS which is having input A. Correct? So this point, E itself is this point. I'll make this connection. This point and this point are same, shorted. Okay. So from drain of A, I am connecting drain of A. This drain of A is connected to this drain of A. Both are common, like this. So this is connected. Okay. If this is taken as drain, this will be source. So what should I take here? Drain source, drain source. Drain source, drain source. Because if I take these two as neighbors, then it is automatically shorted. This point is shorted with this point. I need not short it separately. Like it was here. You know, into source, into source. So it is not short, not आवश्यकता ही ना रखना. It is by default shorted. Okay. So drain source, and source of this goes to ground. And I have to draw the contactors. So here one contactor, here one, then here one, here one. Now you may feel poly and metal are shorted. Some people will feel this is poly and this is metal. Metal is running over the poly. No, like that it is. Hing node is running here. You have to touch it. Hing node is here. Touch again now. Hing is poly is in ground floor. Metal one is in first floor. Okay. So this is contactor. This is contactor. One more contactor here. Here it will be. Yes. This is the layout of two input NAND gate. Any questions? If the given question is two input AND gate, ಏನು ಮಾಡ್ತೀರಿ? This is NAND gate. If the question is AND gate, ಏನು ಮಾಡ್ತೀರಿ? ಇಲ್ಲಿ ಇನ್ವರ್ಟರ್ it will become AND. ಇಲ್ಲೂ ಅದನ್ನೇ ಮಾಡಬೇಕು. ಇದು ಹೆಂಗೆ ಮಾಡ್ತೀರಿ? ಈ ಲೇಔಟ್ ಒಳಗೆ ಏನು ಮಾಡ್ತೀರಿ? ಇದನ್ನು ಇರೇಸ್ ಮಾಡ್ತೀನಿ ನಾನು. I have to place an inverter in front of this. Okay. So for that, what I will do, I can extend this. VDD and ground, or you can take separate also. And what I will do, again I will take P diffusion. And I will take N diffusion. And I will take one more poly. This poly is for common gate of inverter. Okay. Now output of NAND should be given as input for the inverter. Output of NAND should be given as input for the inverter. Okay. Now this metal should be connected to what? It should be connected to what? Poly. This metal should be connected to poly. Okay. But if I bring it and keep it here, will it get connected? If I just bring it and keep it here, will it get connected? No. Connected. हम connection आपको दे रहे हैं, ये connect आगे से चला रहे हैं. ये connect आगे, ये connect आगे. There are different layers. So now I will make use of wire. Okay. So I will just extend this, and I will use wire. So in wire what it will happen? In wire what it will happen? Metal one stays after stays ground floor. We get poly. From here I will get poly. And poly to poly connection will happen. But metal to poly that cannot happen. Therefore I am using a using a stair. From first floor we are going to ground floor and doing the connection. Okay, so this output of NAND is connected to input of inverter. Okay, this is Vi of inverter, and rest connection will do it. Rest connection. This is from source drain to drain connection will do. Okay, again source to ground will do, and place again the contactors. Place the contactors. So this is the layout of 2 input AND gate. See, this analogy is very simple. Now there is one confusion. What is this? What is this? Contactor. What is this? Wire. What is the difference? Difference is very simple. You take two pipes. Okay, this is 2-inch pipe. This is 1-inch pipe. Just try to join them and just pass the water. What will happen? They are not joined because their dimensions are different. One dot is one third. Other connect ಮಾಡಕ್ಕೆ ಏನು ಮಾಡ್ತೀವಿ? 2-inch 1-inch connect ಮಾಡಕ್ಕೆ ಏನು ಮಾಡ್ತೀವಿ? ಒಂದು ಕನೆಕ್ಟರ್ ಇಡ್ತೀವಿ. ಕನೆಕ್ಟರ್ ಏನಂತ ಐ ಡೋಂಟ್ ನೋ ಎಕ್ಸಾಕ್ಟ್ಲಿ. ಪ್ಲಂಬರ್ಸ್ ಯೂಸ್ ಮಾಡ್ತಾರಲ್ಲ, ದೊಡ್ಡ ಪೈಪ್ ಸಣ್ಣ ಪೈಪ್ ಕನೆಕ್ಟ್ ಮಾಡಕ್ಕೆ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಕನೆಕ್ಟರ್ ಇರ್ತಿಲ್ಲ. That is our contactors. Okay. Now what is this wire? Wire is nothing but one pipe first floor nagiti, ಇನ್ನೊಂದು pipe ground floor nagiti. Okay. ಅದಕ್ಕೆ ಹಿಂಗ್ ಕನೆಕ್ಷನ್ ಮಾಡಬೇಕು. ಹೌದಾ ಇಲ್ಲ? ಆ ಕನೆಕ್ಷನ್ ಮಾಡಕ್ಕೆ ಇದನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಬೇರೆ ಬೇರೆ ಫ್ಲೋರ್ ನಾಗ ಇದಲ್ಲ, ಆ ಕನೆಕ್ಷನ್ ಮಾಡಕ್ಕೆ we use something called as wire. Okay. ತಿಳಿತಾ?